everyone. In this video, we're going to take a look at how to find n behavior asymptotes of rational functions. So in order to do this, what you want to do is compare the highest degree of the numerator and denominator when the function is in standard form. So I'm going to write out a couple of rules for you, and then we're going to take a look at some examples. If degree in the numerator is greater than the degree in the denominator, you're going to divide and get a slant asymptote. Now, a slant n behavior asymptote just basically means it's not horizontal. Okay, that's rule number one. Rule number two, if degree in numerator equals the degree in denominator, the n behavior asymptote is y equals the ratio of the coefficients. The ratio of the coefficients of the leading terms. Rule number three, if degree in numerator is less than degree in denominator, the n behavior asymptote is y equals 0. Okay, so make sure you have those rules written down before you watch the examples. Example 1, y equals x squared minus 7x plus 4 divided by x minus 2. So if we compare the degrees, if we compare the highest degrees, the numerator has a highest degree of 2, while the denominator has a highest degree of 1. Remember that anytime there is no exponent on a variable, automatically it's a 1. So in this case, degree of the numerator is bigger than degree of the denominator. So our rule tells us that we should divide. Okay, now I believe that you did this in Algebra 2, so if you need a quick refresher on how to divide using synthetic division, just make sure you ask your teacher. Okay, so I'm going to go through this pretty quickly. I'm going to do x minus 2 into x squared minus 7x plus 4. So for my setup, take the opposite of this 2 right here. Then I line up the coefficients of what I'm dividing into. So 1, negative 7, 4. Drop down that first number, multiply 1 times 2, and then add, multiply, add. So when I look here now, this represents my answer, this 1, negative 5, negative 6, that represents my answer. This is the linear term, this is the constant, and then we have the remainder. I know that because I started with degree 2 and divided by degree 1, so my answer should start with degree 1. That's why this first one is linear. In this situation, guys, we're not going to really care about our remainder. Our remainder doesn't mean anything in this situation. So my n behavior asymptote in this case is going to be the line y equals x minus 5. Okay, here's the coefficient of 1, and here's negative 5, x minus 5. Okay, get ready for your second example. y equals 5x squared plus 1 over x squared minus 2x plus 4. So if I compare my degrees, my highest degrees, the numerator here is 2, the denominator here is 2. So in this case, they're equal. The degree in the numerator equals the degree in the denominator. So my rule tells me that it's going to be y equals the ratio of the coefficients. Remember that the coefficient is the number that's in front of the term, okay? So in the top, my lead coefficient is a 5, and in the bottom, my lead coefficient is a 1. So my end behavior asymptote is going to be 5 over 1, which is the same thing as y equals 5. Horizontal at y equals 5. Okay, last example. Y equals x plus 1 divided by x squared minus 4x. So when you compare the highest degrees at the top and the bottom, notice the top has degree 1, the bottom has degree 2. So your degree in the numerator is less than your degree in the denominator. You don't really have to do any work for this one because the rule tells you that whenever this happens, the end behavior asymptote is going to be y equals 0. Okay, everyone, make sure you have all those rules down. Good luck.